Hey, good afternoon, or morning, or evening, whatever it might be for you. This is AV2, Unit 6, Lesson number 2. So we're going to talk today in this lesson about surface areas for prisms and pyramids. So you can imagine painting all outer surfaces of a solid, like a pyramid or a prism. And that's what we consider the surface area in square units. So anytime we talk area, I want you to think units squared. Okay, so in the previous lesson, we calculated surface areas of walls and of ceilings or roofs, that sort of thing. But not all building surfaces are rectangular. So we could calculate the surface area of a non-rectangular prism using a formula that we're going to develop here in the next couple of slides, as well as for a pyramid. So let's get into it. As mentioned earlier, the surface area is the sum of all of the areas of the faces or surfaces that enclose a solid. We calculate the surface area for many applicable reasons, a lot which have to do with construction or packaging, other professions like those. And of course, in class you can talk to your peers or talk to your teacher about those applications. Let's get into developing the formula for finding the surface area of these two solids. Okay, so let's first talk about prisms. What you'll notice first is that a prism has two bases. Okay, and those two bases, they're always parallel to each other. They're parallel planes, so you can see these two yellow hexagonal bases. They're parallel to each other and they're congruent, meaning they're the same size, same shape. So when it comes to finding the area of each of those, we only have to find it once. Okay, now what do you notice about the lateral faces of the prism? Well, what you'll notice is that they are all rectangles. And the number of rectangles is equal to the number of sides of the base on the base. So in our case, we can see a hexagon has 1, 2, and 3, and 4, and 5, and 6. Therefore, we'll see that we have 6 rectangles. So how could we go about finding the surface area of a right prism? Well, what I'm going to do is I'm going to develop this by sketching out what's called a net. And we saw nets in our previous lesson. Okay, I'm going to sketch out my net by taking a hexagon. This is sketched by hand. Okay, so bear with me here. And I'm going to map this out a little bit. I'm going to draw those 6 rectangles. Bear with my amazing handiwork here. Okay, what I'm doing is I'm unraveling, right, my hexagonal prism. Okay, take a look at this. Here were our 2 bases, yeah? There they are. 2 hexagons of equal area. So the surface area of a prism, oops, that's an R, how about a P? Yep, P-R-I-S-M, is going to be the area of the base times 2, because there are 2 of them, plus what I want is I want this. That's 1, 2, and 2. How about these 6 rectangles? So we could go about that in a couple of different ways. We could find each of the rectangles and multiply it by 6, because they should all be congruent in measure, right? All those lateral faces should be congruent in measure. Or what we could do is we could find them all at once. So this length right here and this height right here, if we knew those two lengths, we could just multiply them together, because this forms one big rectangle, right? So let's think about that green length for a moment. If I were to take this point here and wrap it right onto that vertex, this point here, wrap it to that vertex, this point here, wrap it over here to this vertex, and continue that pattern, this green length ends up being the perimeter of the base. It's cool. So I'm going to take 2 times the area of the base plus the perimeter times this value, and that's going to be the height of the prism. It's going to be a length of one of these lateral edges. We're going to call that the height, and the height is always the distance between the bases. So let me define these again. B is going to be equal to the area of the base. Okay, P is going to be the perimeter of the base. And H is going to be the height of the prism. I'm going to leave that as a lowercase h for now, but we'll see another lowercase h in a few moments. All right, so that's our general formula. Let's carry that with us. All right, here we got ourselves an example. This is great. Okay, now this is called a rectangular prism. Okay, now in the case of a rectangular prism, you have some choices on what you want to define as your bases. I'm going to consider the square that faces the sky and the ground as my bases. So the area of that base, if I were to look at it from a top view, this would be a 4 by 4. So our area of our base would be 16. Okay, so my surface area, let me do a quick substitution here, would be 2 times 16. Okay, so I've taken care of the top and the bottom. Now I need to look at the lateral faces. Okay. Now P, capital P, stands for the perimeter of the base. Right? So if I added up all 4 sides, I'd also get 16. Interesting. Okay, so we're going to take plus 16, which is the perimeter of our base, times the height. Now the height of this will be the distance between the bases, which we're going to call 8. All right, and we could do our calculation based on those values. So 2 times 16 is 32, and 16 times 8 is 80 plus 48, which is 128. So our surface area measure for this rectangular prism is going to be 160. We don't have units, so I'm just going to put units squared. Okay, let's look at another practical example. All right, before we get started, let's take a look at this prism. This is a prism. In this case, what we want to make sure we identify is our bases. And the very typical first mistake is for a student to say, well, the floor has got to be the base, right? Because it touches the ground. Well, that rectangle is not parallel or runs parallel to another rectangular plane up here. So that's not our base. Our base is actually this triangle, right? You can think of the front and the back of the tent, right, as parallel bases. Okay, not like the rectangular prism where you're free to pick. So this is a triangular prism. Okay, So let's write our formula. Surface area will be 2 times the area of the base plus the perimeter of the base times the height of the prism. Okay, so we got to identify some values. First thing I would do is I would probably find h first, right? Because h will determine for you where your bases are located. So h is going to be 15. Okay, I'm not going to trace the third side because it's behind the tent, but you can see that that's the distance between the bases. So I'm going to take 15 feet for the height. So what I want to do here is I want to find the area of this triangle right here. That's going to be B. And then I want to find the perimeter of that triangle, and that's going to be P. So clearly you can see P here is going to be this 10, this 12, and then this length here. I'm going to assume that the tent makers made this symmetrical, so I'm going to assume that's going to be 10 as well. So let's put a 10 there. So our perimeter would be 10 plus 10 plus 12, which will be 32. Okay, now what we got to do is work the area. Now we need this. That length there, I'm going to use, and that's an 8, I believe, if I'm not mistaken. I'm going to use that as the height of the base. So when I calculate the base area, do that down here. The base area is a triangle, so I'm going to take 1/2 base times height. Notice this is the base of the area of the base. This is the base of the base. So this is the base of the triangle. Okay, this is the height of the triangle. Okay, whereas the blue H is the height of the prism, so keep those all straight. Say that 10 times or whatever. Okay, so let's find the area of the base. The area of the base would be 1/2. Base of the triangle is going to be 12. You can see it right here. Remember that the base and the height, when finding the area of a triangle, have to be perpendicular. The height is kind of like the zipper in this case. So the height will be 8. And now we can calculate the area of the base. The area of the base ends up being 1/2 of 96, which is 48. Okay, so let's do a substitution. Find the surface area of this tent. This will be 2 times the area of the base, which we found was 48, plus the perimeter. Put that in green since we've been working with that, which was 32, times the height, which ended up being 15. So using my calculator, I see that the surface area ends up being 96 plus 32 times 15, which is 480. I add those two values together, and I get 576 square feet of material. All right, let's continue. All right, let's look at another example here. Interesting example. Let's find out how much material we need to make for the following pool. Now let's assume we are also making a cover, and that the sides and the bottom and the cover are all made of the same material. Okay, so the base of the pool is a regular polygon with 10 sides. Now I'm going to try to write this. This would be a decagonal prism. All right, you can think of the bases as the cover. It's going to cover this space, and then the bottom, right, which is on top of whatever foundational material they've got there. All right, so I got a decagonal prism. So the area of the base is going to follow the following formula. All right, that's the area of a regular polygon. The perimeter, which is going to be really nice, is actually going to be equivalent to the side length times the number of sides. Remember that from last chapter. And the height will be, the height of the pool, which we'll see here, distance between the bases. Each of these segments here would represent that. Okay, so the height, I think we're told directly, that's 4 feet. Let's dig out some of the other information. Looks like the apothem is given. It's 9.233. So A equals 9.233. Each side has a length of 6 feet. So how about that for S? S is 6 feet. Oops, feet starts with an F. There we go. And N, the number of sides. Well, we know that Decagon has 10 sides. So pretty quickly, I can find P. P is going to be 6 feet times 10 sides, so 60 feet. All right, I already know H. H is 4 feet. So I just got to find B. So the area of the base is going to be 1/2 9.233 times, and I'm going to compact this a little bit. And instead of taking S times N, which is 6 times 10, I'm just going to multiply it by the perimeter, which is 60. So recall that that's another form, right, of the area of a regular polygon, which is apothem times perimeter, instead of apothem times sides times the side length. Okay, so let's find the area of the base, which will be that yellow value here, and we'll plug that in here to the surface area formula, which will be 2 times that value for the area of the base plus perimeter times height. All right, let's get a calculation going here. So that'll be 30 times 9.233, which I'm going to actually round. I'm going to round that just to keep things simple here to 277. The actual value my calculator gave me was 276.99. We'll give you very direct instructions on how to round for any test questions, so don't worry about the ambiguity of that statement there. All right, and P, we already knew it's 60, and H was 4. All right, so I'm going to take 2 times 277. That gives me 554. And I'm going to add that to 240. And that gives me 794. So I need 794 square feet. And that includes, you guys, the cover for the pool. All right, let's move on to working with pyramids. Let's take a deep look into that. Okay, so you won't find this in your notes, but I just wanted to kind of go off on a tangent here. And I'm going to draw myself a pyramid. Ooh, that's kind of a nice pyramid. I kind of like that pyramid. Okay, that's a pyramid. And let's call it a square-based pyramid. Right? So here's my pyramid. Oh, I don't like that though. That doesn't show correct perception. There we go. All right, so here's my square-based pyramid. Okay, so let me unwrap that. Right? Let me make it into a net. Cool. There's my net. I'm gonna draw each of the 4 triangles, and watch how I'm gonna draw them. I'm gonna draw them kind of similar to what I did before. Okay, and let's assume that I'm perfect, which is totally true. Just ask my dog. She's probably the only one that would say that. Okay. And what I'm going to do is I'm going to talk just a little bit about, what we're going to do to find the surface area of the pyramid. So the pyramid is different than the prism in that it has only one base. Right? It's the square base. So it's got one base. So when we calculate the surface area, we no longer need 2 bases. We only need 1. Then what we're going to do is notice this is very similar. This is very similar to the prism. Because if I wrap these points, right? Let me wrap that right there to that vertex. Wrap this one around here to this vertex, and then wrap that back over here. Right? That green length becomes the perimeter of the base. So we get that perimeter idea again. Okay. Now, something different is happening here, though. Okay, so the height of the pyramid is the distance from the center of the base up to the vertex, right? I'm not going to be using the height of the base or of the prism, excuse me, pyramid like I did with the prism. What I'm going to use is what's called the slant height. Okay, and that slant height is going to be the distance from the center of one of the sides of the base up to the vertex. And of course, it's going to form a 90 there. All right, you can visualize that on the net right here. Okay, so for a minute, let's just imagine with me that I create a rectangle. Right? And the height of the rectangle is this blue length, and the base of the rectangle is the green length. So wouldn't I just take the perimeter, which is that green length, times the blue length, which I'm going to call the slant height. Right? It's like a cursive L. Okay, that's cool. But look, I'm missing all of this area. So this goes back to the area of a rectangle and the area of a triangle. What's cool is the red space is actually half of the area of that rectangle. Therefore, I'm going to divide this by 2. And therein, we get the surface area formula for a pyramid. Okay, I'm going to subscript that with a little pyramid. Okay, it's going to be equal to the area of the base plus the, I'm going to take actually and work that 1/2 out in front, times the perimeter of the base times the slant height. And that right there, let's define these. Area of the base, which can differ, right, based on what shape the base is. P is going to be the perimeter of the base. This is a little bit labor intensive, but it's good for later on. And L is the slant height. Okay, there we have it. Let's apply it to a question here. All right, here we go. I got a pyramid. I got some values. I need to determine what the area of my base is, what the perimeter of my base is, and what my slant height is. So check it out. I already know my slant height. I can see it. It's 11 centimeters. I can see it. Okay, I can see my perimeter. My perimeter is going to be this pentagon's perimeter. I see side lengths of 5 and 5 sides, so 5 times 5, that's 25 centimeters. Okay, so the area of the base is again where it gets a little interesting. I'm going to use the formula for the area of a regular polygon. I'm going to take 1/2 times the apothem. And in this case, I'm going to use the perimeter since I already know it. I could take 5 times 5 using side length times number of sides, or SN, and that would give me 25 anyways. So now I'm going to calculate the surface area of the pyramid. Okay, so the surface area will be one base, right, since we're working with a pyramid, plus, don't forget the 1/2, that's very typical, times the perimeter of the base, times the slant height. Okay, so our surface area ends up being, oh gosh, 1.68 times 25 divided by 2. All right, we end up getting 21. 21 for the area of the base. Plus 1/2 of 25 times 11. Well, 25 times 11 ends up being 275, I believe. Yep. So perimeter times slant height gives me this 275. I divide it by 2, and I add it to 21. Looks like our surface area of this pyramid Comes out to be 158.5. That'll be centimeters to the second power. All right, guys. That's it. Lesson 2, surface area of prisms and pyramids. See you in the next video.